Hello and welcome to Simplified Triple Studies. In this short video, I'm going to discuss what do we mean by single slope analog to digital conversion technique. We have already discussed the previous methods of analog to digital conversion that is available in the description box and I button. Kindly visit. Moving on to the discussion on single slope ADC. First of all, let us study what are the different names you can call it as single slope ADC. Single slope ADC is also known as ramp type ADC, or you can call it as voltage to time analog to converter. These are the synonyms of single slope ADC. Now let us understand single slope ADC with the help of a diagram. I request everyone to observe the familiarization of the diagram carefully. In this method, our ultimate target is to convert the analog input voltage into digital output. So this is your input, analog input. We have analog input and this is the digital output. Okay, we require digital information. That is why it is known as ADC, correct? No? Sometimes we have the sensors or transducers which provides only the analog information. But the requirement is digital. Your system works only on digital. So we require this ADC. Now, first of all, I wanted to discuss one thing about slope. What do you mean by slope? So consider a graph. This is your y axis. This will be the x axis. I am getting the curve like this. How to calculate the slope? So slope is nothing but delta y by delta x. Okay, y axis by x axis. Tan theta you can calculate. That is the word meaning of slope. Similarly, another important thing that is called a ramp generator. The function of ramp generator is to produce the ramp signal. So this is one of the example of ramp signal. Okay, y axis, x axis. So this is actually called a ramp. Understanding? Okay. Next thing I wanted to tell you one thing. Comparator. What is a comparator? It compares two signals. Okay. So it may be positive and here it may be negative. So it compares. So VIN1. This may be V. So VIN1. This is VIN2. What comparator does? Comparator compares two inputs. V input 1 minus V input 2. That is the output of comparator. Output of comparator. These are the fundamentals. So I can convince you a little bit better. That's why I'm speaking right from the scratch. Next is called a gate. It's a logic circuit. You must have studied about different type of gates or different type of combinational circuits you must have studied. So gate represents a logic circuit. We have a logic circuit. It will have like off condition, on condition, like that different conditions will be there. Next is actually called a clock. It provides the continuous pulse. It is basically an oscillator or a clock. We can call it as a clock. There is a binary counter. We have a binary counter. It synchronizes with this particular clock. So this is our system. Fine. Now we'll discuss how does it work. So working will be explained in a simplified fashion. So please observe carefully. Our ultimate target is to get the digital information. Okay. So we have the analog input. So we have analog input. So this is your analog input. Everybody observe here. This is your analog input. So first and the foremost, what you're supposed to do is you need to increase the analog input from the sensor. So you keep on increasing the analog input from the sensor. So try to increase the analog input. So like this, the input goes rising initially. Okay. Now, the reference voltage, the output of ramp generator is considered as reference voltage. Correct? So using the comparator, your exact output of sensor, your sensor output, that is going to compare with the output of ramp generator continuously. See, like this, it keeps on increasing. Your input voltage is keep on increasing. Now, I want to add one more point. Whenever the reference voltage is equal to analog input, if your reference voltage is equal to analog input at this point, the ramping will be stopped. Correct? That means the gate will be opened. So case one, gate opened until the analog input is equal to V reference. Until the analog input is equal to V reference. I think you got my point. Until that gate will be opened. Second case, gate is closed. Okay, when the gate will be closed. So after that, so once the analog input is equal to V reference, the gate will be closed. Okay. So till this point, we can say that gate will be opened. So afterwards, we can say that here the gate will be closed. So each case, the counter and clock will be activated until the analog input is equal to V reference. Your clock and counter, binary counter will be activated. Each cases, it is going to provide the digital output. So your analog input, corresponding analog input, you will be getting digital output, binary output you will be getting. So this is the way how single slope or a ramp or voltage to time analog converter work. Why it is called a voltage to time? See, we have the input to voltage, correct? No? You are comparing the voltage. That means the difference between analog input and V reference you are comparing. In parallel, it is compared with the time only. Why it is called a time? Because there is a clock signal. So time is also matters a lot. Each cases, the analog value is going to convert into digital value. This is the way how single slope or ramp or voltage to time analog to converter operate. Let us discuss the pros and cons. What are the pros and cons? The pros, advantage. If I talk about the advantage, the accuracy is very high, precision. Okay, precision. The precision wise, the system is fine. If I talk about the disadvantage, it takes little bit of time to convert the entire analog information to digital information. Time consumption. And these are the major pros and cons of single slope or ramp or voltage to input analog to digital converter. Let me know if you are having any queries. I have written the detailed information here. So you can go through that. I have explained already. So kindly make a note of this so that you can write in your university examination smoothly. So also it will be helpful for recalling the information which I have already explained. Let me know if you are having any questions related to this topic. Don't forget to watch my previous videos also. So I wish you happy learning. Keep and stay tuned. Thank you so much for watching this video.